Hi everyone, I am Dr. R. Soumya, Assistant Professor, Department of Electronics and Communication Engineering. Today we are going to see the subject Sensors and Actuators. Subject code is AU3008. Unit 4 is Automotive Actuators. Under this we are going to see the topic Working Principle, Construction and Location of the stepper motor. Stepper motor is a brushless DC motor that rotate in steps. This unique motion makes stepper motor actuators ideal for applications where fine positioning and repeatable accuracy are required. They are widely used in the robotic automation, CNC machine, 3D printers, and various industrial processes. Step angle is it is defined as the angle through which the stepper motor shaft rotates for each command pulses. It is denoted as beta. So beta, step angle beta equal to ns minus nr by ns into nr into 360 degree. So where ns is the number of stator poles and nr is the number of rotor poles, m is the stator phases. Here beta equal to 360 divided by m into nr. Construction of the stepper motor. The stepper motor is made up of the stator and rotor. The stator is a movable part which has no winding, brushes and commutator. The stator is made up of multipole and multi-phase winding, usually of 3 or 4 phase windings wound for a required number of poles decided by desired angular displacement per input pulses. The components. Stator is a stationary part of the motor. It consists of the stack of laminated iron core with the winding wound around them. The number of windings and their arrangements determine the motor, step angle and the resolution. Rotor is a part of the motor. Can be two main wind types, a permanent magnetic rotor and variable reluctance motor. So permanent magnetic motor contains the permanent magnet that interact with the magnetic field generated by the stator winding. Variable reluctance rotor, it consists of a soft iron core with teeth that align with the stator poles to minimize the magnetic reluctance. Working principle of the stepper motor. The electromagnetic interaction. When the stepper motor have a stator with multiple windings and a rotor with magnetic poles or teeth, when the stator winding are energized in the sequence, they create a magnetic field that pull or push the rotor into alignment with each successive magnetic field. Stepwise rotation. The current is applied to the pulses to the stator winding, producing the distinct steps of movement. Step angle is the degree of rotation. The motor moves with each pulse and depends on the motor construction. The typical step angle is 1.8 degree. Step angle in the stepper motor. The step angle is defined as the angular rotation produced by the stepper motor per pulse given in the circuit. The standard in step angle varies between the 1.8 degree to 1.9 degree, similar to step angle. Better the positional accuracy and higher the number of steps per revolution. The common type of angle is 1.8 degree, gives the resolution of 200 steps per revolution, while 0.9 degree gives the 400 steps per revolution. Micro stepping techniques can produce a step angle less than 1 degree for high precision applications. Resolution equal to number of steps divided by number of revolutions of the rotor. Let us see some types of the stepper motor. The permanent magnet stepper motor construction. It uses the rotor made up of permanent magnet operation. The rotor aligns with the magnetic field generated by the stator coils when they generalized in sequence. Each step occurs as the rotor poles are attracted to stator poles. Variable reluctance stepper motor. The rotor is toothed iron core with no permanent magnet. The stator has a multiple electromagnetic poles with coil. It works on the principle of the magnetic reluctance. The rotor aligns with the lowest reluctance path formed by the energized stator coil. The stator magnetic field changes the direction step by step, pulling the rotor teeth into the alignment. Next one is a hybrid stepper motor. It combines the features of the both permanent magnet and the variable reluctance motor. The motor consists of a tooth-end permanent magnet, and the stator has a complex winding pattern. This is mainly used in the CNC machines, 3D printers, medical equipments, and robotics. Next one is a unipolar stepper motor. It has a single winding per phase with a center tap, which allows the current to flow in only one direction in each half of the winding. It is mainly used in the low power applications such as small robots and hobby projects. Bipolar stepper motor. It has a single winding per phase but without center tap. Requires reversing the current direction in each phase of two-step. It is mainly used in the industrial applications, 3D printing, robotics, where high torque is needed. Applications of the stepper motor are CNC machines, 3D printing, in robotics, satellite antenna positioning, and washing machine, refrigerators, etc. Thank you.